Welcome to 4.1. This is the introduction to matrices. We're going to organize data into matrices and solve equations involving matrices. So let's start with some vocab. So a matrix is a regular array of variables or constants in horizontal rows and vertical columns enclosed in brackets. An element is a value in a matrix. The dimensions is a matrix with m rows and n columns. So it has a dimension of m by n matrix. So here's an example of a matrix. We got the brackets, we got 4 rows, we got 3 columns. The element 15, the number 15, is in row 4, column 2, and it is a 4 by 3 matrix. So that's the basic idea of a matrix. So let's look at creating a matrix. So Sharon wants to install cable television in her new apartment. There are 2 cable companies in the area whose prices are listed below. We're going to use a matrix to organize the information. When is each company's services less expensive? So let's start by figuring out what's our rows, what's our columns. I'm going to make my rows the 2 different cable companies, Metro Cable and Cable City. And then I'm going to do my columns as each product. Basic service, standard service, and then our premium channels. So here we got a 2 by 5, and again we did basic, standard, standard plus 1, standard plus 2, standard plus 3. Okay. Metro Cable has the best price for standard service and standard plus 1 premium channel, but Cable City has the best price for the other categories. So that's the basic setup of how to create a matrix. Example 2, dimensions of matrix. So here state the dimensions of matrix B. It's all about how many columns and how many rows. Since matrix B has 3 rows and 2 columns, the dimensions of matrix B is 3 by 2. So there are some vocab words based off of their matrix dimensions. So a row matrix is a matrix with only 1 row. Column matrix is a matrix with only 1 column. A square matrix is a matrix with the same number of rows as columns. And a zero matrix is a matrix where every element is 0. So now let's look at equal matrices. So an equal matrix are 2 matrices with the same dimensions, and each element of one matrix is equal to the corresponding element of the other matrix. So our example here, these are not equal matrices because they have different dimensions. These are not equal matrices because their corresponding elements are not equal. 1 is equal to 1, yes, but 2 is not equal to 8. The matrices have the same dimensions. Their corresponding elements are the same. Therefore, the matrices are equal. So we can actually solve equations using matrices, knowing that we can have equal matrices. So here we're going to solve an equation. We're given a 2 by 1 matrix for both of them. They have the same dimensions. Since the matrices are equal, the corresponding elements are equal. When you write the sentences to show the equality, 2 linear equations are formed. So here, y equals 6 minus 2x, and 3x equals 31 plus 4y. The system can be solved using substitution. We're going to substitute into the second equation. Instead of y, we're going to put 6 minus 2x. Then we're going to use the distributive property. We're going to add 8x to each side. And we're going to divide each side by 11. To find the value for y, substitute 5 for x in either equation. We're going to substitute into the first equation. And then we're going to simplify, and we get the solution is 5, negative 4. Okay. That's it for equations and basics of matrices. Good luck on the practice.